Okay, this is lesson 6.5, parallel and perpendicular lines. The goal of this lesson is to explain how the slopes of parallel and perpendicular lines are related. So first, what is a parallel line? Well, parallel lines are lines that run in the same direction and never cross. And the slopes of parallel lines, if they never cross and run in the same direction, means that they have to be the same slope, which means that parallel lines will never intersect with each other. So if we wanted to prove two lines were parallel, and we knew what the lines look like on a graph, to prove that they're parallel, we'd have to show that they have the same slope. So I'm going to call this line A, and I'm going to call this one line B. So we're going to find the slope of A. So I'm going to say that that's M of A. And to find the slope of A, we'd have to find its rise and run. So I'm going to pick 2 points on A that I can read nicely. So let's say this one and this one. And I'm going to find its slope between these 2 points. So that'd be 1, 2, 3 down, 1, 2 across. -3, 2. My rise is -3, my run is 2. So my slope is -3 over 2. So that means that the slope of B, M of B, is the same. We have parallel lines. So let's look for some points. And this one looks good, crosses nicely. And if I keep going, we cross here. And actually, these look like the exact same points, just on the other line. So I think we're in good shape here. 1, 2, 3 down, which is the same as the other one, and 1, 2 across, which is the same as the other line. So we have the same slope, rise of -3 divided by run of 2. So since the slopes are the same, MA equals MB, the lines are parallel. The lines A and B are parallel. And that's how we can show that two lines on a graph are parallel, show that their slopes are the same. Perpendicular lines. Well, perpendicular lines are lines that intersect at a right angle. And to show that two lines intersect at a right angle, it means that the slopes of these two lines are something called a negative reciprocal. And we're going to discuss why once we find the slopes. A negative reciprocal just means that the two numbers, if you multiply them together, give you -1. So for example, the number 2 and -1/2. If you multiply those two numbers together, you get -1. So I'm going to show you the slopes of two lines, and we're going to decide whether or not they're perpendicular. Or we're going to show that they are perpendicular by showing that they're negative reciprocals. So I've got my two lines here. I'm going to call this line A, and I'm going to call this line B. So let's find the slope between these 2 points on A. So it looks like it's over 1, 2, 3, 4, 5, 6, 7, 8, and down 1, 2, 3, 4, 5, 6, 7, 8. Run of 8, rise of -8. The slope of A is -8 over 8, which is -1. Let's find the slope of B. B, we're going to go between these 2 points on line B. So we got a run, 1, 2, 3, 4, 5, 6, 7, 8, run of 8, and a rise of 1, 2, 3, 4, 5, 6, 7, 8. Up is positive, right is positive, so we've got 8 over 8. 8 divided by 8 is 1. The slope of B is 1. And if we multiply these two slopes, if we get -1, it means the slopes are perpendicular. So that means if we take the slope A and multiply it by slope B, we should get -1. So let's find out. That is -1 for the slope of MA times 1. And if we multiply those, we do get -1, which means, therefore, line A, and line B are perpendicular. So why negative reciprocals for the slopes of perpendicular lines? Well, for lines to cross at a right angle, one is going to have to be a positive slope, and one is going to have to be a negative slope, except for in one case, but we won't worry about that right now. A is decreasing, B is increasing. That gives them a chance to cross at a right angle. And the slopes kind of have to be opposites for them to cross at 90 degrees. So opposite means that if we flip the fraction. So this one doesn't really show it very well, but this one might show it a little bit better. If 2 was the original number, it as a fraction would be 2 over 1. 1 over 2 is just that fraction flipped upside down. So that gives you the 90-degree part, and the fact that one of them is positive and one of them is negative gives you the fact that they're going to cross in opposite directions, which gives you the crossing at right angles. So negative reciprocals. Flipped fractions, so opposite fraction, opposite sign. 1 over 1, if you flip that fraction, is just 1, so that's why these ones aren't fractions. But let's look at another example of negative reciprocals, just so you kind of get a better idea as to what negative reciprocals are. Here's some steps. Find the negative reciprocal of negative 6. The first step is to divide 1 by the given number. So that means do 1 over the number. Or flip the fraction, if it's a fraction. So negative 6 is not a fraction unless you write it as negative 6 over 1. So if you flip that fraction, you get 1 over negative 6. So that would be 1 over negative 6, which is the same as negative 1 over 6. Writing 1 over the number would just be writing 1 over negative 6. So either of these descriptions gives you the same answer, negative 1 over 6. Step 2, multiply the answer by negative 1. What that does is really it just switches the sign. Flip the fraction, switch the sign. So instead of negative 1 over 6, if we multiplied it by negative 1, we would get 1 over 6. So 1 over 6 and negative 6 are negative reciprocals. And to prove it, let's multiply them. Negative 6 times 1 over 6. If we multiply those and the answer is negative 1, we have a negative reciprocal. Negative 6 times 1 is negative 6. And 1 times 6, if we're multiplying across the bottom of the fraction, give you 6. Negative 6 divided by 6 is negative 1. So we've got it right. We have negative reciprocals. So basically, if we have two numbers and they're opposites, so that means the numerator and denominator are flipped, and the signs are opposites, we have negative reciprocals. So another example of negative reciprocals, I'll show you really quickly. If we had 3 over 2, the negative reciprocal of 3 over 2 would be negative 2 over 3. Flip the fraction, change the sign. I'll do another one. If we had negative 6, we just did that example. That was silly. Let's say negative 6 over 5. Flip the fraction, change the sign. Flip the fraction, 5 over 6, change the sign. Instead of negative, we have positive. Okay? I don't know if you get the hang of it. Hopefully you do. Flip the fraction, change the sign. If it's not a fraction to start with, you can write it as a fraction, then flip it, and then change the sign. All right. Now we have a good understanding of what parallel and perpendicular lines are and how to prove it. I'll flip the page here. Here's the equation of two lines. We're going to decide whether the two lines are parallel or perpendicular or neither. First pair, y equals 3x minus 5, y equals 6 over 2x plus 10. Either way, we're going to be comparing the slopes. So what's the slope of our first line? Well, it's 3. And the slope of our second line? 6 over 2. 6 divided by 2 is 3. the slopes are the same. When the slopes are the same, the lines are parallel. Sometimes the slopes might look different, but if we simplify it to 3, we end up getting the same number. So these slopes are the same. Let's try another one. B, we've got y equals negative 3x plus 2, and y equals 1 over 3x minus 2. We're going to compare the slopes. Slope of the first one is negative 3. The slope of our second line is 1 over 3. Remember, the slopes come from the number in front of x, the constant of variation. These are not the same, so it's not parallel. Let's see if they're negative reciprocals. To show that, we can just multiply. Negative 3 times 1 over 3. To multiply fractions, you multiply across the top. Negative 3 times 1 is negative 3. 1 times 3, 3. Negative 3 divided by 3, negative 1. Since the product is negative 1, the slopes are perpendicular. Slopes are negative reciprocals. Therefore, lines are perpendicular. All right. So if we know the two lines, we just have to see if the slopes are the same. If they're the same, they're parallel. If the slopes are negative reciprocals, same number, or sorry, different signs, similar fraction. 1 over 3, 3 over 1. Flipped fractions, 3 over 1, 1 over 3, opposite sign, negative, positive. That shows they're negative reciprocals, or just multiply them, and if you get negative 1, they're negative reciprocals. All right, example 5. For each of the following lines, write the equation of 2 parallel and 2 perpendicular lines. Let's see if I can get all the way down and cover it up perfectly. Perfect. 2 parallel, 2 perpendicular. So we want 2 lines with the same slope, 2 lines with negative reciprocal slopes. So let's start with this one. Let's do parallel. 2 parallel lines. So we want 2 lines with the same slope. Well, if the slope is negative 3 over 4, that's the part they can't change. They both have to have negative 3 over 4x. And the b part doesn't matter. For it to be parallel, they have to have the same slope, but they should have different b values. If they're the same, the lines would just be on top of each other. So let's pick any number that's not 5. So we'll go with 4 and negative 17. We now have 2 different lines, because they have different starting points, with the same slope, which means that we have 2 parallel lines. To find perpendicular lines, we need lines with negative reciprocal slopes. So the negative reciprocal, I'm going to say neg recip. What's the negative reciprocal of 3 over 4? Well, flip the fraction, 4 over 3, and change the sign, not negative, positive. So we need 2 lines that have a slope of 4 over 3. So I'm going to start by writing y equals 4 over 3x. And the y-intercept can be anything. It does not matter. Let's say 5. It could be the same. And let's say negative 2. Any number for the y-intercept. The only part that matters is the slope. The slope has to be the negative reciprocal. All right. The next one I'm going to get you to try. But before you do, I want you to notice that this equation is not in y equals mx plus b form. You need to change it to y equals mx plus b form before you write the equations of other lines, because you need the slope. You can't see the slope here. So I'm going to do a little bit of work. I'm going to change this to y equals mx plus b for you, and then you'll tell me the equation of 2 parallel and 2 perpendicular. So I'm going to move the 6y to the other side to make it positive. So I've got 6y equals 3x minus 24. I'm going to divide everything by 6 to make it say y equals 24 divided by 6, or sorry, negative 24 divided by 6 is negative 6 times 4 is 24, so negative 6. Nope, messed that up. Negative 4. And 3 divided by 6, if we simplify that fraction, is 1/2. So my equation is y equals 1/2 x minus 4. We want to find two parallel equations, so two equations with the same slope, and two equations with the negative reciprocal slope. I'm going to leave that up to you. You can do that now, or you can wait till the end of the video to try it. We're now going to move on to example 6. Example 6. Are the lines L1 and L2 passing through the given pairs of points parallel, perpendicular, or neither? So we've got L1 passing through these 2 points, and we've got L2 passing through these 2 points. To find out if they're parallel, perpendicular, or neither, we need their slopes. So we need to know what the slope of L1 is. We don't have a graph, so we can't just count the slope, but we do have 2 points. If you have 2 points, you can find the slope using the equation y2 minus y1 over x2 minus x1, something we saw last unit. x1, y1, x2, y2 come from the points that the line crosses. x1, y1 come from the first point. x2, y2 come from the second point. If we plug these in, we'll get the equation of the line. y2 is -7 minus y1, -1, minus -1. x2 is 5, subtract x1, 2. -7 subtract -1 is like -7 plus 1, which is -6. And 5 minus 2 is 3. So our slope is -2. That's the slope of line 1. To find the slope of line 2, we use the same equation. y2 minus y1 over x2 minus x1. x1 and y1 come from the first point. x2 and y2 come from the second point. Let's plug it in. y2 is 2. y1 is 0. 2 minus 0. x2 is -1. x1 is 0. We've got 2 minus 0, which is 2, and -1 minus 0, which is -1. 2 divided by -1 is -2. The slope of the first line is -2. The slope of the second line is -2. Those are the same number. ML1 is the same as ML2. Therefore, what can we conclude? Well, since it's the same slope, the lines must be parallel. If this slope was 1/2, 1/2 and -2 are negative reciprocals, we would have perpendicular lines. If L2 is anything else other than -2 or 1/2, it would be neither. So what I'm going to get you to do is, after the video, I'm going to get you to try this pair. Find the slope of both, compare them to see if it's perpendicular, parallel, or neither. And you can check your answer on the course website, and I'll have this question completed for you to check. Thanks for watching 6.4, and I'll see you next time in lesson 6.5.